All right, so slope-intercept. It has two parts. Again, mathematicians are not very creative, so it deals with a slope and it deals with an intercept. So there are two parts that make up this whole idea, this concept. So let's again begin at the beginning. Let's redefine slope. We know quite a few formulas for slope. One of them is the change in y over the change in x. The change in y over the change in x, which is also written, remember, with that delta. It's a way of abbreviating the phrase change. Change in y over change in x. What's another formula for slope? y2 minus y1 over x2 minus x1. Right, that's if they give us an ordered pair. You subtract the y's, you subtract the x's, it's the change in y, subtracting, and the change in x, subtracting. And there's one more if they give us a picture. Good, Sam. Rise over run. You start at the bottom dot and count up. Turn the corner and go to the top dot to count over. Three things you should remember about slope. 1, it is always a fraction. But what if it's not a fraction? I just contradicted myself. What if it's not a fraction? Emma? Make it into 1. If it's 5, how do you make it into a fraction? 5 over 1. Slope is always a fraction. Sometimes it's improper. Not meaning it doesn't forget to say please and thank you. What is an improper fraction? When the numerator, top number, is greater than, bigger than the denominator, the bottom number. 3 over 2. And number 3, it is never a mixed number or decimal. Slope is always a fraction, it sometimes can be improper, and it's never a mixed number or a decimal. Mixed number would be a whole number and a fraction, 1 and 1/2. Decimal, never make it 0.5. It's always a fraction, never improper, or sometimes improper, never a mixed number or a decimal. This coming back to you? Lie to me and say yes. The next part is the intercept. So we know it's slope, so it involves a fraction. The next part is intercept. And we studied intercepts already. What does intercept mean? Oh, Sam's looking through his notebook because all this information is in there in previous pages. Intercept. We studied intercepts. In fact, we studied 2 types of intercepts. Corbin, what's an intercept?
Where a line intersects with the X and Y axis.
Yeah, it's where a line crosses an axis. And we only care right now about the y-intercept. So we look for the point where the line crosses the y-axis. And we only care about the y-intercept. The x-intercept is kind of a thing of the past. We've moved on to bigger and better things. All right, I'm going to give you a graph. So if you'll get out your glue sticks, we're going to glue this graph down because I'm kind and generous. And I want you to have a pretty graph. If your box is missing a glue stick, so today on your homework, you're going to be asked to graph some information. But before we graph, we need to talk about slope-intercept form. Hold on, we're not gluing yet. Slope-intercept form. And of course, there's a formula. And this formula needs to be committed to memory, never again to be forgotten. And the form is y equals mx plus b. M is where the slope goes. Whatever number touches the variable x is your slope. And whatever value is plus b, right? That sign belongs with it. So if it said minus 6, that minus belongs with the 6. This right here, the b value, is your y-intercept. Okay, here we go. I'm going to give you a problem, and we're going to graph it. So write down this equation, and then we're going to glue our graph down underneath it. Y equals negative 1/3 x plus 6. So write down y equals negative 1/3 x plus 6. And I'm going to take my graph, and I'm going to glue it underneath there. So the first thing I need to do is I need to identify the m, and I need to identify the b, the slope and the y-intercept. Looking at this formula, y equals mx plus b, what letter is my m, my slope? Keegan? Negative 1/3, perfect. And I'm going to assign the negative to the top number. You can put it on the bottom number and it doesn't matter. But I always like to assign it to one or the other, to the numerator or the denominator. Don't leave it hanging out front. Give it to one of the numbers. And what's my y-intercept? 6. Positive 6. And now it's time to graph. Alphabetical order is the key to math. So which one do you think we start with? B. So I find negative 6, the y-intercept, and I put it, or positive 6. I find it and I put a dot. Because it's positive 6, and this is the y-intercept. It intercepts the y-axis at 6. Now I'm going to do my slope. And remember, slope when it's a picture is rise over run. So from this dot, I'm going to rise negative 1, and I'm going to run 3. What does that look like? Why do you say down 1? Yeah, my rise is a negative number, so that means I have to go down. Down 1. And my run is positive 3. So which way is positive 3? Which way is it going positive? To the right. 1, 2, 3. Put a dot. My rule of thumb is you need 3 dots if it's possible. So let's do it again. Negative 1 over 3. And then I connect to make my line. And if I check it, does that make the diagonal in the letter N? Yeah, so it's a negative slope. Want to do another? What if I tried to trick you? All right, let's glue down our next graph right over here. And let's do y equals 2x. So again, to graph it, I have to find my m and my b. Looking at that equation, can you identify the m, the slope? It's whatever touches the variable x. But wait a second, I thought it had to be a fraction. What touches x? 2. So how do I make it a fraction? 2 over 1. What's being added or subtracted? Nothing. What number means nothing? 0. So let's graph it. Where does my line start? Start alphabetically. It starts at 0. So the y-intercept is 0. Some students find it helpful to highlight that y-axis, telling them that's where they start. All right, and then we do our slope. Rise over run. What do we do? Rise over run. What does that look like, Sam? Up 2, because it's positive 2, and to the right 1, because it's positive 1. I like to do my slope as many times as it fits, because the more dots you have, the straighter your line is. Can anyone think of an equivalent fraction to 2 over 2, or 1? 2 over 1. What's another way of writing that? What's the exact same? Corbin? 4 over 2, but that doesn't get me down here. How do I get down here? Negative 2 over negative 1 is the exact same as 2 over 1. How come? 2 negatives make a positive. So I can even put more dots on here because I can go down 2 and backward 1. Down 2 and backward 1. Because more dots means your line is straighter. And this concept is going to come in really handy when we work with something called systems. And there's my equation. There's my graph. All right, let's just identify. We've graphed. Let's just identify. Write down that equation and tell me the M and the B. Write down that equation and tell me the M and the B. Raise your hand if you can tell me the M and the B for that equation. M and B. Greta? What's the B? Perfect. The B is negative 3. So if I graphed that, I would start down here at negative 3. And then do my slope of 1/2 up 1 over 2. Okay, let's do another one. Let's see. How about y equals negative 8x plus 2. Y equals negative 8x plus 2. Who can tell me the M? Who can tell me the B? Miles? I thought it always had to be a fraction. Perfect. Negative 8 over 1. And what's the B, Samantha? Positive 2. All right, I'm going to trick you. Y equals 4. What's the M? What's the B? Keegan, what's the N? What touches the letter X? Nothing. What number means nothing? 0. And what's your Y-intercept? 4. So that means you start at 4. How do you make 0 into a fraction? 0 over 1. So you'd go, start at 4 and you'd go up 0 over 1. Up 0 over 1. Easier than you thought it was going to be? You only have 12 problems for homework.